Hey YouTube, thanks for visiting. Hopefully you're doing well. So thanks for showing your interest for the question practice session on Wbset 2023, the upcoming Wbset 2023. Okay, so let's try to practice. Or this is the first session. Okay, and in this session we are going to discuss the questions, some questions from real analysis. Okay, and you all know that real analysis is a very important chapter for any higher mathematics exam. Okay, so let's start. And this is my WhatsApp group, so you can just join my WhatsApp group by scanning this barcode. Okay, for the Wbset, CSIR-NET and GATE and any higher mathematics exams. Okay, so and those who are not watching me for the first time, so I'll say one thing, that Wbset, the previous year questions paper of Wbset 2022 का paper, 2020 का paper, जो previous papers have, so we already have the solutions of this paper available. Okay, you just go to my channel and search see the Wbset mathematics paper. Okay, so and you will get the previous year paper solutions of this of the question of the Wbset 2023 on that playlist. Okay, so let's start. And before starting, I am requesting you to all those who are new in my channel, please give like to this video, share with your friends, and if you like this content, then you can subscribe my channel. Okay, so let's start. So the first question is, what is the sum of the following series? Okay, so it is, the series is given that 1 by 2 into 3 plus 1 by 2 square into 3 plus, this is the first term, then 1 by 2 square into 3 square plus 1 by 2 cube into 3 square and plus 1. So if you write the series by rearranging the terms, so this is, we can write 1 by 2 into 3, that is the first term first. Okay, first terms are first, 1 by 2 into 3, 1 by 2 square into 3 square plus so on, and plus the next terms are 1 by 2 square into 3 plus 1 by 2 cube into 3 square and plus so on. And here nth term is also given. So we can write this term as summation 1 by 6 to the power n. So we can write this term 1 by 6, then 1 by 6 square and so on, plus, and if we take 1 by 2 common from here, then we can also write 1 by 6 to the power n, this series. Okay, summation n equal to 1 to infinity. Okay, now this series will be like what, this is the like GP series. Okay, so we all know that the sum of the GP series. So if we common take summation 1 by n, then 1 plus 1 by 2 into summation, this will be 1 by 6 to the power n. So this is equal to simple 3 by 2 into summation 6 to the 1 by 6 to the power n, means a equal to 1 by 6 here and r equal to also 1 by 6 here. So we all know the sum of the GP series is a by 1 minus r, 1 minus 1 by 6. So this is equal to 3 by 2 into 1 by 6 by 5 by 6. So 6 equals to cancel. So 3 by 2 into 5, that is, this is equal to 3 by 10. Okay, so the answer is option B, 3 by 10. Now going to the next question. The next question is S1 equal to, this is given 1 by 3 minus 1 by 2 into 1 by 3 square plus 1 by 3 into 1 by 3 cube and so on. So if we just take x equal to 1 by 3, then if we see that in this series, so S1 equal to, we can write x minus x square by 2 plus x cube by 3 plus x to the minus, this is minus x to the power 4 by 4 plus and so on. So this series is nothing but log of 1 plus x series. Okay, and if we put now the value of x, so this is equal to log of 1 plus 1 by 3. So this is equal to log of 4 by 3. Now see this series 2, S2, this is equal to 1 by 4 plus 1 by 2 into 1 by 4 square plus 1 by 3 into 1 by 4 to the power 3 plus so on. Now if we take minus common from here, so we can write minus of 1 by 4 minus 1 by 4 minus 1 by 2 into 1 by 4 square minus 1 by 3 into 1 by 4 cube and so on. Okay, so now if we take this 1 by 4, this is equal to y, if we say, then this is minus, this is x minus x square by 2 minus x cube by 3 and so on. So this series is nothing but so this is y, right? Okay, so this is nothing but minus log of 1 minus y Now if we put y is equal to 1 by 4, then this series becomes minus log of 1 minus 1 by 4. So this is equal to minus log of 3 by 4. So this is equal to log of 4 by 3. So the sum of the series are same. Okay, so that is the option is S1 equal to S2. Option D. Okay, next question. So see the next question, the find limit n tends to infinity 1 by n to the power 4 and j equal to 0 to 2n minus 1 jq, this is equals to. So this is very easy problem, and if these types of problem we solve by using the integration. Okay, so limit n tends to infinity, we write 1 by n and summation j equal to 0 to 2n minus 1 j by n whole cube we can write. Okay, so now this is equal to, we write the integration. Okay, so if we put just j by n, this is equal to x, then what happen? The lower limit of the integration, how can we find? Limit and put in this term we put the lower limit, the starting value of j, that is 0 by n, limit n tends to infinity. So this is equal to 0, and the upper value like limit n tends to infinity j by n, put here the upper limit of the j, that is 2n minus 1 by n. Okay, so this is equal to limit n tends to infinity 2 minus 1 by n, which is equal to 2. So integration 0 to 2. Okay, so j by x equal to x, that is x cube, and 1 by n dj equal to dx. So this is dx. Okay, so this is simple integration x to the power 4 by 4 0 to 2. So this is equal to 2 to the power 4 by 4 minus 0. So this is equal to 4 simply. Okay, so the answer is option 1. Next question, and if you like this video, then obviously to like, comment and share. Okay, so let gnx equal to nx by 1 plus n square x square, x belongs to 0 infinity, and this is questions from sequence and sequence of function. Okay, then which of the following series uniformly pointwise and the function. So we first find the limit function, okay, or the pointwise limit. So fx equal to what? Limit n tends to infinity fnx. Okay, so this is equal to limit n tends to infinity fnx, means nx by 1 plus n square x square. And see, since the value of n, the degree of n is in the denominator is greater than the numerator, then obviously this is equal to 0 for all x. So here option C and D says that gn tends to x. No, gn tends to x by 1 plus x square. No, gn tends to 0, but whether uniformly or pointwise we can check. So this is pointwise limit, that means pointwise is sure. Now we check the uniform case. So here we apply the Mn test. So Mn equal to supremum of x belongs to 0 infinity gnx minus of gx. Okay, so this is equal to supremum of gnx, means nx by 1 plus n square x square minus 0. Now the supremum value for at x equal to what happened, or x equal to which point, we can find by using two process. So we can just putting y is equal to nx by 1 plus n square x square and find y dash x, and then put y dash x equal to 0, and we can find. And another method is, this is one method, and number 2 method is we just put denominator equal to 0 irrespective of sign, that is 1 plus n square x square is equal to 0. This implies n square x square is equal to 1. We not write here minus 1. This is irrespective of sign. We just write the value. Okay. So this is equal to x equal to, we can write 1 by n if we take positive sign. So this is because this is modulus. Okay. So this is supremum of x equal to 1 by n, means n into 1 by n by 1 plus n square into 1 by n square. That is, this is equal to 1 by 1 plus 1. This is 1 by 2. So Mn does not tends to 0 as n tends to infinity. That is, this convergence of Gn is not uniform. That is, option A is true here. Now next question. This is also a question from sequence of function. For n greater or equal to 1, let fn x equal to x to the power minus n x square. X belongs to R. Then the sequence fn is uniformly convergent, convergent only, bounded, and so on. There are so many options. Now we again first find the limit. F of x, this is equal to limit n tends to infinity fn x. Okay, so this is equal to limit n tends to infinity x by e to the power minus e to the power n x square. Again, see, this is exponential power as n tends to infinity. Obviously this is 0 for all x. Okay, so now obviously this is pointwise convergent. Okay, so pointwise convergent, so there is no option, there is uniformly convergent. Okay, so it option B says that only on compact subset of R. No, this is not correct, because it is for all x belongs to R. Clear? True. Okay, so we can discard option B, bounded and not uniformly convergent. So if this is bounded, then obviously this is uniformly convergent implies bounded. So we do not discard this option now. Now we can find similarly a Mn test. So Mn is equal to supremum of supremum of fn x minus fx. So this is equal to supremum of x belongs to R. Okay, so this is supremum of x, fn x means x e to the power minus n x square minus 0. Now we here apply the next term, the other policy, that is y equal to, if we write x e to the power minus n x square, and now if we find y dash, this is equal to e to the power minus n x square and minus x n e to the power minus x square into x, I think, yeah, 2x. This is 2x, n x square means 2x. Okay, so we can take common e to the power minus n x square 1 minus 2n x square. Okay, so now if we put this is equal to 0, then we get this is not equal to 0, so we get x is equal to 1 by root under of 2n, I think. Okay, so this is the value of x, or x square is equal to 1 by 2n. So if we put, then x equal to 1 by root of 2n into a to the power minus n into x square by 1 by x square means 1 by 2n. So this is simply 1 by root of 2n into e to the power minus of half, and this is a fixed value, and this is 1 by root over 2n, that is this is, it tends to 0 as n tends to infinity. Okay, this is tends to 0 as n tends to infinity. I think you can see this. Okay, so that is Mn, limit of Mn is equal to 0, limit Mn is equal to 0, that is this is uniformly convergent. So option A is clearly correct here, and here it is says that not uniformly convergent. No, it's false. The sequence of unbounded functions, no, since this is uniformly convergent, that is it is convergent, that is it is bounded, obviously. Okay, not of unbounded functions. Okay, so we can discard also this one. Next question, let fn x equal to 1 minus nx. Okay, for x belongs to 0, 1 by n closed interval, and 0 for x belongs to 1 by n 1, then defines continuous functions, converges uniformly, 0 exists and so on. Again we first find the limit function. This is also a question from sequence of functions. So fx, this is equal to limit of fn x n tends to infinity 1 minus nx. Okay, so this is equal to, if we put x is equal to 0, then the value is 1 and 1 by n. So if we put x is equal to 1 by n, then the value is 0. Okay, and otherwise if we put at 1 x equal to 1, if we put x equal to 1, then what is the value? 1 minus n, as n tends to infinity, so it's like infinity like. And if 0 less x less 1 by n, okay, then what is the value? X equal to 1 by n, so this is I think 0 again, yeah, it is 0 again. So see, yes, at x equal to 1 what happened? X equal to 1 to 0, it is defined, and x equal to 1 it is also 0, and at 0 less x less 1 by n it is like 0. Okay, right, fine. So see, now option A says that it defines a continuous function, but limit at the point 0, it is 1 at x equal to 0 and this is 0. So that is, it is f n x is not, sorry, fx is not continuous at the point 0. So now we get, we think we know one theorem that if fn is converges pointwise and f is not continuous, then the convergence of fn is not uniform. So that is, this is, since this is not continuous, so this implies this is not uniform continuity or uniform convergence. Okay, so option B is incorrect one, and this is limit does not exist at x equal to 0, so continuity से कोई बात ही नहीं है, option B भी correct है, ठीक है. And it says that limit fn x is equal to 0 for all x belongs to 0 to 1, no, because at these three cases 0 and we get 1 in this case. So option C is also discarded, that is option D is clearly correct. Limit n tends to infinity just exist. Okay, we don't say that this is completely 0 or the function fx is continuous or like that. Okay, so next question, let fn x is equal to x to the power 1 by n for x belongs to 0 to 1, then limit n tends to infinity fn x exists for all x, and here the continuous constants are given. So here again we can first find the fx, the limit function, n tends to infinity x to the power 1 by n. So this is equal to, if we put x equal to 0, then the value is 0 at x equal to 0. At x equal to 1, it is also 1, and for 0 less x less 1 by n, this is like 1 by n, this is also 1, I think. Okay, this is also 1. Just a second, I will check once whether this is also wrong. Yes. Okay, so see, at the point 0, again here at 0 and here at 0, so f is not continuous at 0. So this implies the convergence of not uniform converges, not uniform converges. So it's option C says uniformly convergence, no. Fn completely 0, this is also not correct because the limit are different for different value of x. Okay, so fx defines a continuous function, limit does not exist, that means this is also not continuous, and that means option A is true. Again, these two questions are like same types of questions. Okay, just the function is different. Okay, so I think you will enjoy this class. So if you enjoy, then obviously don't forget to like and share with your friends, obviously, and if you new here, then don't forget to subscribe. Okay, so now next question, consider the series summation 1 by n to the power 3 by 2 sin 3x. The series converges uniformly, converges pointwise, converges in L1 norm in to an integrable function 2 pi, but not converges uniformly, does not. So see, the series is given by summation n equal to, I think, 1 to infinity, so n to the power 3 by 2 sin 3x. Now here we apply what? The comparison test we can easily apply. So mod of n to the power 3 by 2 sin 3x, this is less equal to, you can write n to the power 1 by n to the power 3 by 2, 1 by n to the power 1 by n to the power 3 by 2. Okay, so because mod of sin x, sin 3x less equal to 1. Okay, and summation 1 by n to the power 3 by 2, this is convergent by p test. I think you all know that summation n to the power p converges for all p greater than 1 and diverges for p less equal to 1. This is the p test, and now we get a series summation n less equal to, or mod n less equal to mod of bn. Then if summation bn converges, if summation bn converges, this implies summation n also converges. So the summation bn means here this summation 1 by n to the power 3 by 2. So this is converges. That means by comparison test we can say that the series 1 by n to the power 3 by 2 sin 3x, this series converges uniformly for all x belongs to R. So option A is correct. Now converges pointwise but not uniform, no. Not uniform, no. Not converges, no. Uniform means obviously pointwise. This is a question from function of several variable. Okay. So if xy is equal to root under xy mod of xy, then what is the option is true. So fx fy we first check. So fx fy fx at 0 0, this is equal to, we all know that limit h tends to 0, the formula is f of h0 minus f00 by h, and f00 means here f of 00 it is not given, and you can also define this is equal to complete 0. So this is equal to limit h tends to 0 root under of h mod of h into 0 and minus 0 by h. So this is complete, the numerator is 0 means complete 0. And similarly here you can write f y00, this is equal to limit k tends to 0 f of 0k minus f of 00 by k, and this is also f of 0k is what? F of 0k is root under of mod of 0 into k, it is complete 0 and it is also 0. So 0 minus 0 by k, so this is complete 0. But option A says that fx fy does not exist. No, it's false. fx00 equal to 1 but it's 0, it is also false. fy00 equal to 0, yes, it's true. And f is differentiable at 0 0. So I think how can we check that this is not differentiable or not? So we can find, or if we can write f of a plus h and b plus k, this is equal to so first you can check whether it is continuous or not. So if it is not continuous, then it is not differentiable. And we can also say one thing, but if it's differentiable or not. So we can also notice one thing, that for any fixed y, so if we take y is equal to, if we fixed value suppose k, then f of x, this is equal to what? Root under of k into mod of k into x. Now if we take limit as x tends to if we choose the path or x tends to 0 for y equal to mx or size, like no like that. So this is mod k outside of the mod, so root over of mod k and root over of mod x. And we all know that this type of modulus of function, mod of x minus 0 type function, is not differentiable at 0. Okay, so it is not differentiable at 0 for fixed y. So we can say that if we now vary fixed one variable and vary one variable, we can easily notice that this function is not differentiable at 0 0. Otherwise you can check also by definition, but this is the easiest way, this is the shortcut tips. Okay, because also you can say that if this function is not continuous, then this is not differentiable, because differentiability implies continuity. So the contrapositive is not continuous implies not differentiable. We can also check by that. Okay, so there are different various types of methods we can check whether it is continuous, differentiable or not. I can share one shortcut tips in the next question. This is the question. So see, let fxy equal to 2xy, f of xy, this is equal to 2xy by x square plus y square, and 0 otherwise f0. fxy exists, f0, f is not continuous, f is continuous, exist, and f is continuous, f is discontinuous, exist continuous. So you can first find fx00. Okay, so fx00, no, I first check the continuity. Here one shortcut tips, you remind that if the functions is like x to the power a, y to the power b by x to the power c plus y to the power d, these types of function, then this is continuous if a by c plus b by d is greater than 1. So this is a shortcut tip you must remember. Okay, this is very useful tips. Okay, now कंटिन्यूटी केस चेक कर लेते. सो हियर तो 2 एक कांस्टेंट है, इसको बाहर ही रख सकते हो, ठीक है. ओके, सो सी इट्स x a equal to what if we compare 1, b equal to 1, c equal to 2 and d equal to 2. So a by c plus b by d is equal to 1 by 2 plus 1 by 2 is equal to 1. It is not greater than 1. If it is strictly greater than 1, then we say that this is continuous. So this is not continuous. Otherwise you can check by using the x equal to r cos theta, y equal to r sin theta. Otherwise you can also check by y equal to mx. So there are 3 different procedure to check whether it is continuous or not. Also you can check by another method. If you check another method, if we put y equal to mx, then this is like 2 m x square by x square. If we take common 1 plus m square, so this is depends on m. So this is not continuous. This is second method, and the third method is x equal to r cos theta, y equal to r sin theta, polar value if we put, and if we get that it is a fixed limit or unique limit or finite limit, then it is continuous, otherwise not. So f is continuous? No. So f is continuous? No. F is discontinuous and does not exist. So we can first now find fx 0 0. So fx 0 0 equal to limit h tends to 0. I change the color. Okay, f of h 0 minus f 0 0 by h. F of h 0 means if we put here f of h 0, then this is also 0. So limit h tends to 0, 0 minus 0 by h, this is 0. Similarly f y 0 0 you can check, this is 0. That is fx fy both exists. Okay, but it says that it does not exist. No, it is also false. Option B is correct. Next question, same question. देखो fx y equal to given f x y is equal to x y by x square plus y square. Similarly you can check x to the power a, y to the power b by x to the power c plus y to the power d. A by c plus b by d, this is equal to 1 by 2 plus 1 by 2, this is equal to 1. It is not greater than 1. That is, it is not continuous. So you can easily check. So option A says that it is continuous. No, false. None of this also for नहीं तो देखते. So f is discontinuous, yes, this is true, and fx y exist. So again same. So you can also simply check that fx 0 0, obviously this is exist. This is just half into the previous function कर ले तो हो जाएगा, ठीक है. तो limit h tends to 0, I think f of h 0 minus f of 0 0 by h, and f of h 0 means obviously 0 because this is product, so this is 0, and similarly f y 0 0, again this is 0. So it is discontinuous at 0 0, but fx fy exist. Yes, this is correct. Fx fy only at 0 0. Okay, at every point, and it is says that 0 0. But if we calculate another point, just like xy not equal to 0 0, right? So if we find how can we find fx fy? How can we find? So just fx ab, this is equal to what? Now f at ab, this is equal to ab by a square plus b square. This is a finite value obviously. So fx ab like limit x tends to xy, obviously no, this is not, this is h tends to 0. H tends to 0, f of what? F of a plus h and b plus 0. F of h 0, I think this is the formula, minus f of ab, b plus k to no. Okay, I think this is h. So this is a finite value. Also this is also a finite value. So I can write. So limit h tends to 0. f of a plus h means a plus h into b by a plus h whole square plus b square minus f of ab means ab by a square plus b square by complete h. Okay, yeah, this is the value. Now if we put h, I think h should be cut, cancel out. So limit h tends to 0. If we take, see, we can take AB common from here. So if we take AB common, then it is 1 by a plus h whole square plus b square minus hb by a plus h, no, minus this one, 1 by, sorry, minus 1 by a square plus b square and plus bh by a plus h whole square plus b square by complete h. So I think this is exist for all point, not only for 0 0. Okay, so you can once check just any another point and you can find a finite limit. Okay, so it is not only 0 0, it exists for every point in R2. If you have any problem or if you facing any problem, then you can comment me, I will again solve this problem. Okay, now again question, it says that let a r cross r2r be defined by if xy is equal to 4x square plus 9y square by this one, and then this, and this is c belongs to r is a fixed constant, then the following statement is true. So you have to find the true statement. Okay, now just a second. Okay, so first find, it says that f is continuous at 0 0 if c equal to 0, continuous at 0 0 c equal to 10, continuous at 0 0 c equal to 16. It does not exist a value of c for which it is continuous. Okay, so see, we can check whether the function is continuous is or not for the first, okay. So if we go to the polar coordinate, x equal to we can write 3 cos theta and y equal to 2 sin theta. Okay, then f r theta, this is equal to what, 4 x square means, so 4 x square means 9 cos square theta, that is total 36 into cos square theta plus sin square theta by root under of 4x square means again 36, so total 36 common, cos square theta plus sin square theta plus 64 minus 8. So this is equal to 36 by 36 plus 64 under the root 10 minus 8. So is equal to 36 by 2. This is equal to 18. So this is a finite value, not dependent on theta. That is r theta tends to 0 or r theta tends to yes. At the limit, if you take any limit, then this is a fixed value because this is constant. So you can get a finite limit which is constant. So that means this is obviously continuous. Okay, so we first check whether it is continuous or not. So there does not exist any value. So yes, it is continuous. So we can discard option A. Now, how can we find the value of C? Clear? Now, how can we find? How can we find? Yes. So see, that means this is obviously continuous. Now we can choose any limit. Okay, so if we choose any path, suppose at y equal to 0, that is the limit on the x-axis. If we put, obviously that is, this is f(x), this is equal to so we can find limit. So limit just x tends to 0, this is 4 x square plus 0 by root under of 4 x square plus 64 minus 8, and yes, we can write this equal to c, the value of c. Okay, So this is equal to 0 by 0 function. Just a second. So now limit x tends to 0, 4x square into root under of 4x square plus 64 plus 8 by 4x square plus 64 minus 64. So 4x square goes to cancel this. So this is equal to, if we put 0, then this is root under 0 plus 64 plus 8, this is equal to C. So this implies 8 plus 8, this is equal to C. That is the value of C equal to 16. Okay, B and C are incorrect. Okay, so since this is exists, so we can put any value, that is for choosing any path the limit obviously exists and this is equal to the functional value. So we worked that thing. Okay, so this is the easiest process to solve the question, or this is the shortcut tricks you can take. Okay, next question. So it says that f from R2 to R be defined by fx equal to this one, the directional derivative at the point 0 0 in the direction 1 by root 2 1 by root 2. So see, directional derivative we can use two process. One is simply grad f dot u, u is the unit direction, and second one is the several variable formula. Why this formula and why these two formula, and when we apply these two formula? See, if f is differentiable, if you completely sure that f is differentiable, then apply this one, and if you are not sure that whether f is differentiable or not, this is second formula, that is several variable formula. Okay, so directional derivative equal to the formula is limit h tends to 0, limit h tends to 0, f of a plus h u minus f of a by h, or u is the direction u1 u2 in two variable calculus and a equal to the point a1 a2. Okay, so here at the point a1, so that is a equal to 0 0 and u is equal to yes, this is, see, this is unit direction, so u is equal to 1 by root 2 1 by root 2. Okay, now you can simply put, so limit h tends to 0, f of 0 plus h1 into u means 1 by root 2 comma then 0 plus h2 by root 2. Sorry, this is not h1 h2, it is only h. Okay, minus f00 means 0 by h is equal to limit h tends to 0, u means 2 vector and a means a point in 2 dimension. Okay, limit h tends to 0, f of h by root 2, that is this is equal to h by root 2 sorry h by root 2 square into h by root 2 by h by root 2 to the power 4, that is h to the power 4 by 4 plus y square means h square by 2 simple by h. Okay, this is equal to limit h tends to 0, this is h cube by 2 root 2 by, and this h should be what it is h square. If we take common h square, then it is h square by 4 plus 1 by 2 into h. So see, h square, h cube and h cube cancel out. Okay, so this is equal to 1 by 2 root 2 into limit h tends to 0, 1 by h square by 4 plus 1 by 2. So if we put the value, then this is equal to 1 by 2 root 2, and simply this is 1 by, this is 0, 1 by 1 by 2, 1 by 1 by 2. This is equal to 1 by 2 root 2 into 2. So this is equal to simply 1 by root 2. So option A is the answer. Next question. So this is very easy question, I think you all know. the procedure. See, let a from R to R be defined by fx is equal to x to the power 4 if x is irrational and h to x square minus 1 if x is irrational. You all know, I think, if hx is equal to fx and so g1x and g2x, for this is rational and this is irrational, then hx is continuous at the point when fx or g1x minus g2x is equal to 0, that is g1x is equal to g2x. So we can simply put x to the power 4 equal to 2x square minus 1 at the point continuous at this point. So x to the power 4 minus 2x square plus 1, this is equal to 0. This is x square minus 1 whole square, this is equal to 0, that is x square minus 1 equal to 0, that is x equal to plus minus 1. So the continuous at the point only plus minus 1. Okay, these both point, s equal to 1, only 1 point, here only 1 point, phi, these 2 point. Next question. So this is again we also limit n tends to apply infinity n plus 1 integration 0 to 1 x to the power n ln x dx, this is equal to. Here shortcut tips, tricks क्या है? So 1, if f is continuous on 0 1, here since 0 1 the limit is given, then number 1 is limit n tends to infinity integration 0 to 1 x to the power n fx dx is equal to 0, and number 2 is limit n tends to infinity n integration 0 to 1 x to the power n fx dx, this is equal to f of 0. Okay, this is the formula. Just a second, I will check once. Okay, sorry, f of not 0, f of upper limit 1. Okay, so now here the limit is limit n tends to infinity. We can break two parts, n integration 0 to 1 x to the power n ln 1 plus x dx plus limit n tends to infinity, this is 1, so simply 0 to 1 x to the power n ln 1 plus x dx. So fx equal to what? Here fx is equal to, this is the formula. Okay, now fx is equal to what? Fx is equal to ln 1 plus x, which is obviously continuous on 0 1, no problem. So we can apply this result. Okay, so this is equal to n x to the power n into 0 1, that is this is f1, that is this is ln of 1 plus 1 plus this complete value is 0, so this is ln 2. Okay, so this is a very simple tricks or the simple technique to solve this type of problem within a few seconds. Okay, next question. This is a question comes from SET exam, obviously West Bengal SET. It is very basic problem. So which of the following function is continuous at x equal to 0? So without pen and paper you can solve this problem. So limit x tends to 0, sin 1 by x does not exist, sin 1 by x square it is also does not exist, tan inverse 1 by x does not exist. Simple, this is the answer. Okay, these three are not exist at the point 0 or at x tends to 0. Okay, limit does not exist. Next question. Okay, so it says that if r equal to, this is also question from SET, root under a square plus b square equal and phi equal to tan inverse b by a, then the nth derivative of e to the power ax cos bx plus c is. Okay, fine. So we have to find the derivative, nth derivative. Now we find first or second derivative and compare these four options. Okay, this is the easiest way to solve the problem. Now how can we solve the problem? See, here it is given phi equal to this and phi r equal to this, so we can just consider r equal to a equal to, we can just consider a equal to r cos phi and b equal to r sin phi. Then these two conditions satisfied. Okay. Yes, a square plus b square equal to r square. Okay, tan inverse by equal to phi. Okay. See, now function y equal to given here e to the power ax cos of bx plus c. Now y dash, this is equal to a e to the power ax cos bx plus c minus e to the power ax into b sin of bx plus c. So this is e to the power ax common. Okay, a cos bx plus c minus b sin px plus c. Now if we put r cos phi, r sin phi, a and b in this bracket, not in the out of the bracket term. Okay, we just put in the bracket term e to the power ax, otherwise you cannot match the exam answers. So a equal to r cos phi, so r cos phi into cos of bx plus c, okay, minus r sin phi sin bx plus c. Okay, now if we take r common, then cos phi cos a cos b minus sin a sin b, that is cos of a plus b. So r e to the power ax cos of phi plus bx plus c. So this. So see, here two terms are in sin. So for n equal to 1, this is obviously cos. So these are not in sin terms. So we can discard a and c. Okay. Now here r and r to the power n. Okay. So but we cannot say that this is to r or r to the power n. So we have to go to the next term or next derivative term. So from here we can derivative the second term y dash, y double dash. So y double dash, this is equal to a e to the power ax. Okay, and these two terms are same. Or otherwise, how can we derivative? I think from here we can derivative easily, because r is a square plus b square and we have to derivative with respect to this term. So r from the last, it is r a e to the power ax cos of phi plus bx plus c, and minus, I think it will be minus r e to the power ax sin phi plus bx plus c. Okay, fine. But can I write r a r here also r present? So now we can write a equal to r cos phi. Okay, so r square cos phi cos of phi plus bx plus c minus, but here anything not present. Okay, there will be 1b. Okay, 1b. So minus r, here 1 e to the power term ax term present, to the power x. So e to the power ax r, b means r sin phi. So r square sin phi sin of phi plus bx plus c. So if we take common r square e to the power ax, then this is cos phi cos this and sin phi sin this. So that is what? This will be again cos of a plus b. So cos of phi plus this. So cos of 2 phi plus bx plus c. So see, for the second derivative it is r square. So simply we can see by induction, for nth derivative this will be r to the power n. So this D option goes incorrect. Option B is correct. Next, because it is r to the power n and here also n phi, and here it is 2 phi. For n equal to 1 it is only phi, n equal to 2 it is 2 pi, for n equal to n it is n5. Now the coefficient of x to the power 4 in the Maclaurin's expansion of log of cos x, fine, which is very easy. Log of cos x, this is equal to log of, we first write the series of cos, cos series is 1 minus, this is, can just write 1 minus the series is cos of x square by 2 factorial plus x by 3 factorial minus and so on, and log of 1 minus x series is what, minus x square by 2, yes, minus x cube by 3 and so on. So this is log of 1 minus x square by 2 factorial minus x cube by 3 factorial, okay, 1 plus minus minus, this is again minus plus and so on, okay. So this is equal to log of, this means minus of x, minus of this x square by 2 factorial minus x cube by 3 factorial plus x to the power 4 by 4 factorial, yes, yeah, I think we said right, and so on, minus, then minus x square by 2 minus 1 by 2 into x square, this is x square by 2 factorial minus x cube by 3 factorial plus so on, this square and plus so on, because we need the coefficient of x square, and these terms contains the hard terms of x square, okay. So x square coefficient is here, from we get minus 1 by 4 factorial, yes, minus 1 by 4 factorial, and minus, if we square this term, then this is 2 means 2, so 4, this is plus 1 by 8, okay. So this is minus 1 by 4 factorial means 24, I think, plus 1 by 8, so this is 24 and minus 1 plus 3, so minus, oh, sorry, yes, I think it will be right, minus, this is 1 minus plus minus 1 minus, this is minus, this should, if we take minus common from here, then this is minus, then plus, okay, and 1, oh sorry, this term is plus, I think, log of 1 minus x, all terms are minus, this is minus, so 1 by 2 factorial into this term, square means 4 into 8, minus 1 by 8, this is minus 1 by 8, okay, and oh sorry, I think 1 minus is present, x to the power 4, this is plus minus plus, if we take minus common, then minus plus minus, I think this will be plus, okay, and this is minus, so you can once check once, this is plus and this is minus, minus 2 by 24 minus 1 by 12, this is the answer, okay. You just check once the plus minus terms once, okay, I think it will be correct answer, okay. This is the, just you will check once. Next and the last question, writing the mean value theorem, fb minus fa equal to b minus f dash c, a less than c less than b, the value of c for fx is equal to 1. So we all know that the mean value theorem, and it is also given here, fb minus fa by b minus a, this is equal to f dash c here. So here b equal to 1, a equal to 0 and fx is equal to x into x minus 2. So here f dash c, this is equal to f1 minus f0 by 1 minus 0, and f dash c is, this is x square minus 2x, so f dash c is equal to 2c minus 2, this implies 2c minus 2, this is equal to f1 is 1 into 1 minus 2, f of 1 this is equal to 1 into 1 minus 2, this is minus 1, and f0 is equal to 0. So 1 minus 0 by 1 minus 0, this implies 2 into c minus 1, this is equal to 1, that is c minus 1 equal to 1 by 2. F1, this is minus 1, sorry, f1 is minus 1 minus 1 minus 1 by 2. So c equal to 1 minus 1 by 2, this is equal to 1 by 2. That is option B is the correct answer. Okay, so these are the 19 problems of real analysis, mixed problem of real analysis, and I think this session is very helpful for your upcoming West Bengal SET exam, and this is also for CSIR-NET GATE exams also helpful for, okay, because I take the questions from CSIR-NET pyqs, GATE pyqs, and the SET pyqs. Okay, so if this session is helpful, then obviously let me know in the comment section. Don't forget to like, obviously, and if you have anything, if you have any query, or if you have any suggestions, then obviously let me know in the comment section by doing a comment. Okay, so I can expect a comment from you, obviously. So thank you. मिलते हैं अगला वीडियो में. Okay, bye.